Welcome back everyone. Today is the session 6 from the chapter of moving charges and magnetism, and this is the Q&A session. And in this session I have taken one question which was asked in the CBSE All India Pre-Medical Test in the year uh, 2010. CBSE All India Pre-Medical Test in the year 2010. So this was the question which was asked in this examination, and the question here is: a beam of cathode ray is subjected to a cross electric and magnetic field such that the beam is not deflected. So in this case we have to find the specific charge of the cathode ray. Now cathode ray basically is an electron beam, and here the specific charge is the ratio of E upon m, where E is the charge on the electron and m is the mass of the electron. And cathode ray is basically a beam of electron. So we can say that a beam of electron is subjected to a cross electric and magnetic field such that the beam is not deflected. The specific charge of the cathode ray is to be found out, and we have been given 4 alternatives here. So, since the beam or this electron beam is subjected to a cross electric and magnetic field and it is not getting deflected, it means that the electrostatic force due to this electric field and the magnetic force due to this magnetic field on this electron are equal, and that is the reason why this beam is not getting deflected. So, the magnetic force due to the magnetic field due to the magnetic field will be equal to the electrostatic force due to the electric field. Now the magnetic force is given by Q V into B, and this electrostatic force is equal to Q into E. Q into V into B is the magnitude of the magnetic force, and Q into E is the magnitude of the electrostatic force. This electrostatic force is due to this electric field, and the magnetic force is due to the magnetic field. And since the electric field and the magnetic field are perpendicular to each other and the beam is not deflected, therefore the magnitude of this will happen only when the magnitude of this magnetic force is equal to the magnitude of the electrostatic force. So in this case, now here Q is the charge on the electron, V is the velocity of this electron, B is the magnitude of the magnetic field, and here E is the intensity of the electric field. So from this equation we are getting the velocity of the electron as E upon B. So this is the first relation which I have got from this equation. Now, since the electron is moving from the cathode towards the anode, so and since the potential difference between this the cathode and the anode is equal to V, therefore the potential energy of the electron, potential energy of the electron at the cathode will be equal to E into V, where V is the this is the potential difference between the anode and the cathode, and E is the magnitude of the charge on the electron. And now when this electron moves from the cathode towards the anode, then what will happen that this entire potential energy will get converted into the kinetic energy at the anode. That is, the potential energy at cathode will be equal to the kinetic energy at anode. And this is this potential energy at the cathode will be equal to the kinetic energy at the anode by the law of conservation of energy. So the potential energy of the cathode of this at the so the potential energy of the electron at the cathode is equal to E into V, and the kinetic energy will be equal to half mv square, where m is the mass of the electron and v is the velocity of the electron, and this will be equal to E into V. Okay, this will be equal to E into V, where this is the potential energy of the electron at the cathode, and this is going to get converted entirely into the kinetic energy at the anode, and by the law of conservation of energy, both these, that is the potential energy at the cathode, should be equal to the kinetic energy at the anode. So I got this equation, that is EV is equal to half mv square. And now what I will be doing is I will be substituting the value of v. This is the velocity of the electron, which I have found from the relation, that is q vb is equal to qe, because the beam, this electron beam is not deflected, and it is subjected to a this electric field and the magnetic field, which are perpendicular to each other. So when a beam, this electron beam is subjected to an electric field and the magnetic field, which are perpendicular to each other, and it is not getting deflected, then it means that the magnetic force due to the magnetic field should be equal to the electrostatic force due to the electric field. And from this relation I have found the value of the velocity of this electron, and I will be using this this formula in this equation. So substituting the value of this v, that is the velocity of the electron, in this equation, I will be getting as EV is equal to half m E upon b whole square. Now the specific charge of the this cathode ray is equal to E upon m, where E is the charge on the electron and m is the mass of the electron. So we have to find basically the value of E upon m. So from this equation, I can write that E upon m will be equal to E square divided by 2 VB square. What I have done is that this m, I have shifted this m on the left hand side of this equation, and this V, that is the potential difference between the cathode and the anode, has been shifted on the right side of this equation. So in this way we have got the value of E upon m, which is equal to E square, that is E square divided by 2VB square. So the correct option is D, that is E square divided by 2VB square. So in this question we have used two concepts. First thing is that since the electron beam is not deflected and it is subjected to the electric field and the magnetic field, which are perpendicular to each other, therefore the magnetic force will be equal to the electrostatic force, and using that relation we were able to find the velocity of the electron, which was equal to E upon B. And second thing was that the potential energy of the electron at the cathode will get converted into the kinetic energy at the anode by the law of conservation of energy. So using these two concepts we were able to derive this equation, and from this equation we were able to get the specific charge of the cathode ray, which was equal to E square divided by 2V, where V is the velocity, this potential difference between the cathode and the anode, B is the intensity of the magnetic field, and E is the intensity of the electric field. Okay? So this is the answer, and the correct option is D. I hope you have understood the solution of this question. So hope to see you again, and in the next session I will be taking up few more questions from the same chapter. So till then, have a nice day. Bye.